All right, our last section of chapter 6 is talking about systems of inequalities. So now instead of doing systems of equations, we're talking about systems of inequalities. So you got to think back to when we did our last chapter on inequalities. That will come in handy here. So we're going to solve all of these by graphing. So example 1, we're solving by graphing this system of linear equations. So the thing to remember from the last chapter that we talked about is if you have a greater than or equal to or less than or equal to sign, that means you're going to graph a solid line. If you have a greater than sign or a less than sign, remember that means you're going to graph a dotted line. So keep that in mind here. All right, so on example 1a, the first equation, or excuse me, first inequality is y is less than or equal to 3. So, first of all, I look at that sign, that tells me I'm going to graph a solid line. When we have an inequality or an equation that's just y and a number, remember we look at our y-axis, x is the horizontal axis, y is the vertical axis, and I'm going to count up 3 and make a dot there. Then, since this is a solid line, all I'm going to do is draw a straight line through those points. My pen wants me to make it dotted, but just like that. So there is my first line. Now I'm going to graph the other one. I'm going to do this in, actually before I graph that one, let's go ahead and actually shade this. So remember when we graph inequalities, we have to shade them. So first of all, if I'm shading y is less than or equal to 3, I'm going to plug in 0, 0 as a test point. Remember 0, 0 is our origin right here. That's what we're plugging in as a test point. So my y value is 0, plug in 0 for y. I check to make sure 0 is less than or equal to 3. This is true. So that means I'm going to shade the part of the graph that has 0, 0 in it. So I'm going to shade below this line where that x is. X marks the spot. All right, now I'm going to move ahead and graph the other line. I'm going to do this in blue so that we can tell the difference between the two. So I have, whoops, I didn't switch it. There we go. So I have x plus y is greater than or equal to 1. First, I got to get this in a slope-intercept form so I can graph it. So I'll subtract x from each side. Now I have y is greater than or equal to negative x plus 1. Now I can go ahead and graph this. My slope-intercept is 1, and my slope is negative x. I'm going to go down 1 over 1. Remember, if it's negative x, that's like negative 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1. When you're graphing inequalities, it's very important to cover the whole span of the graph. That will make your answer much more succinct. From that y-intercept, I can also go up 1 and back 1. So I'm going to do that as well, all the way across this graph. You'll see why this is important in a second. All right, and again on this one, I have a solid line because it's or equal to. So I'm going to graph that as a solid line. I'll draw a solid line through those points. There we are. Now I got to figure out where to shade. So I'm going to plug in 0, 0 again. You can plug it into this equation, or you can plug it into the original equation. It's up to you. I'll plug it into the original one here. So I have 0 plus 0 is greater than or equal to 1. 0 is greater than or equal to 1. This is not true. So that means I'm going to shade the part of the graph that does not have that x, that does not have that origin there. So I'm going to shade this half of my graph. All right, so then my answer is where these two actually overlap. So I'm going to draw this in a different color. This section where the blue and the black overlap, that is my solution. So my solution set is right here. This will be very helpful if you have multiple colors. It'll make it a lot easier on you. So we did our solution to example 1a. Let's go ahead and do another one. So on 1b here, let me switch back to black. On 1b here, I take that first inequality, 2x plus y, maybe, is greater than or equal to 2. And I got to get it into y equals mx plus b form. So I subtract 2x from both sides, and I have y is greater than or equal to negative 2x plus 2. All right, again, this is greater than or equal to, so I'm going to have a solid line. And now I can go ahead and graph that. So I plug in, let me scroll back up to my graph here. I plug in 2 as my y-intercept, so 2, right about there. Then my slope is negative 2, so negative 2 over 1. I go down 2, back 1, down 2, over 1, down 2, over 1, down 2, over 1. From that y-intercept, I can also go up 2 and back 1, up 2, back 1, and so on. Then, since I know it's a solid line, I'm going to draw that solid line through there. Let me give that another go. That was pretty bad. Let's see here. All right, a little better, not great. Okay, so now I got to do my test point to figure out where to shade. So I'm plugging in 0, 0 into that equation. If I plug in 2 times 0 plus 0 is greater than or equal to 2. This becomes 0 plus 0 is greater than or equal to 2. 0 is greater than or equal to 2, which is not true. So again, that means I shade the part that does not have 0, 0 in it. 0, 0 is the origin here. I'm going to shade the part that does not have that, which is on that right-hand side. All right, now I'm going to do the other equation. So I'm going to switch to this one being in blue. So I have 2x plus y is less than 4. I'm going to get it into y equals mx plus b form. So I have y is less than negative 2x plus 4. Now I can graph this. My y-intercept is 4. And now my slope is negative 2, just like the other equation. Think ahead a little bit now. You guys have these tools to see this. These have the same slope. That means they're going to be parallel lines. So from there, I'm going to count down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and so on. And I can also go up 2 and back 1. All right, this one is just a less than sign, so that means I'm going to do a dotted line. So let's draw a dotted line through those points. Something like that. Now I got to figure out where to shade. So I plug in 0, 0, which becomes 2 times 0 plus 0 is less than 4. 2 times 0 is 0, plus 0 gives me 0. So I'm asking now, is 0 less than 4? Yes, this is a true statement. So that means I'm going to shade the left side of that line because that's where 0, 0 is on the graph. So now you'll notice my answer here is where these two colors overlap. On this particular graph, that ends up being kind of between these lines. So along this line, along this dotted line, this is getting very messy, so that's why it's important to use multiple colors. And my answer is that shaded part in the middle. So this is a little sloppy, but it's that shaded part between those two lines. Go ahead and try this next one on your own. I can come around and help you as you're working. So pause the video and then I'll get to you on the next page. All right, now we're looking at situations where we have no solution. So in this case, we have y is greater than 3 and y is less than 1. So again, I noticed that on both of these equations, I can start with that right off the bat, they're both going to have dotted lines. And they both just have y's in them. So again, that means, I'm going to switch back to black here. That means on my graph, I'm looking for 3 on the y-axis. So from that origin, I count up to 3. Then I'm going to draw a horizontal dotted line through that point. So something like that. There's y is greater than 3. So in y is greater than 3, I'm going to plug in my test point. Remember, my test point is right here, the origin. So I plug in 0, 0. 0 is the y value, so I plug in 0 for y. And it's telling me 0 is greater than 3. Well, this is not true. So that means I'm going to shade the part above the line, because that's not where 0, 0 is. Now for the other equation, I'm going to switch to blue. So the other equation is y is less than 1. So again, I start at 1 on the y-axis, so 1 up from the origin. I'm going to draw a horizontal line through that point. Now I plug in my test point, 0, 0, into y is less than 1. So I plug in 0 for y, 0 is less than 1. 0 is indeed less than 1, so this is true. So I'm going to shade the part that includes 0, 0. So that happens to be below the line. So you'll notice here that the shadings don't overlap. There's that empty space in between here. This part is empty. So that means my answer then is, you describe your answer as no solution. There's no part of this where the shadings overlap. So we just say no solution. Go ahead and try the next one on your own. I can come around and help you, and then we'll move on to the next page. So pause the video for a second. All right, so now a word problem, everyone's favorite thing in the whole wide world. Okay, so our word problem says, the theater club is selling shirts. They have only enough supplies to print 120 shirts. They will sell sweatshirts for $22 and t-shirts for $15, with a goal of at least $2,000 in sales. All right, so letter A tells us to define the variables, write a system of inequalities to represent the situation. Okay, so we're trying to figure out how many sweatshirts they should get, how many they should print to sell, and how many t-shirts they should print to sell. So for letter A, I'm going to define some variables. I'm going to let S represent the number of sweatshirts. And the other form of shirt that they can sell is a t-shirt. So I'm going to let T represent t-shirts. All right, now I got to come up with some inequalities. So the first piece of information we know is they have only enough supplies to print 120 shirts. So 120 shirts total. So I know that the number of sweatshirts plus the number of t-shirts has to be less than 120 shirts. That's the max. So I'm going to say less than or equal to 120 shirts. They could print 120, but they do not have to. Then I also know from that second piece of information that they will sell sweatshirts for $22 and t-shirts for $15 with a goal of at least $2,000 in sales. So they want to earn at least $2,000. So if they sell sweatshirts at $22 per sweatshirt and they're selling t-shirts at $15 per t-shirt, they need that amount to exceed 2,000. So it has to be greater than or equal to 2,000. All right, so we're going to go ahead and graph this situation. On this graph over here, again, we're only looking at positive numbers. So I'm going to graph this as if the x-axis is the S-axis for sweatshirts and the y-axis is the t-axis for t-shirts. I'll help you set up the scale and then I'll have you guys try this one on your own as well. So our scale is a little bit different here. So what I'm going to suggest you do is make the scale on both of these going up by 15. So 15, 30, 45, 60, 75, 90, 105, 120, and then lastly 135. That should allow you to graph all of your information. Same thing across that bottom part. I'm going to do 15, followed by 30, followed by 45, 60. This is getting very crowded. 75, 90, 105, 120, and lastly 135. Okay, so you might need to count those out by 15 because my handwriting got very sloppy. Go ahead and try to graph those, and then we'll talk about how we determine what possible solutions are.